The lesson outcome for this video is, I can graph and solve an inequality. All right, so the first question here is, what is different here? We have 3x minus 4 equals 11, which should seem familiar from what we've been doing. And then we've got 3x minus 4 is greater than 11. Well, obviously what you probably will notice is the difference is we have a greater than symbol instead of an equal sign. Now what that means is that we are dealing with inequalities. Remember that equal signs means we have an equation. The equa part in equation means there's an equal sign. Whereas now we've got this greater than symbol, which means we have an inequality. And an inequality means that it's not equal, right? So not equal would mean an inequality. But instead we've got some other symbols we use for inequalities instead of an equal sign. We use greater than, where something on this side would be greater than something on this side. We use less than, and then we use greater than or equal to, so there could be the equal to part involved, and then there's the less than or equal to. So those are the four symbols we'll be using. I'll get rid of this here and this here. These are the four symbols we'll be using for our inequalities. Greater than, less than, greater than or equal to, and less than or equal to. So when we're working with inequalities, an important thing to realize or notice is that inequalities are not going to have just one number as their solution. It's not going to have just one number, or even two for that matter, or three or four. An inequality has a set of points that are all solutions. If you think for a minute about something like, I am, meaning you as a student, greater than 10 years old, it doesn't mean you're 10, okay? It could mean, since it says you're greater than 10 years old, that might mean you're 11 years old, or 12, or 13, or 14, 15, 16, 17, 18, 19, 20. It goes on forever after 10. So x is greater than 10 tells us that a person, if we're using that example in real life, a person is greater than 10 years old. There is a set of solutions, a set of answers that could be the true age of you. So in this example right here, I'm just asking, so what is the solution? The first one says x is less than 3. X is less than 3. So if we're thinking about what are all the possible solutions for x is less than 3, well, we know that 2 is less than 3. We know that 1 is less than 3. 0 is less than 3, and so are all the negatives. But there's another couple of answers, and we're going to take a look at this number line here. This is going to be how we show our solution on a number line. So first of all, I'm going to put this number 3 right here. All right, and our inequality right here is x is less than 3. Okay, that means, for example, 2 is a solution, but over here, 4 is not. Okay, 1 is a solution, and 0 would be a solution. And again, all the negative answers that show up to the left, so -1, etc. Again, numbers over here like 5, 6, and 7 are not going to be a part of the solution. But here's the thing. We can't just say the solutions are 2, 1, 0, -1, because anything that's in between those values will also be solutions. For example, isn't right here 1.5, isn't that a solution to x is less than 3? So what we have to do is we have to shade on the number line any value that is less than 3. When we use less than symbols, and I'm going to show you this on the next page, when we use less than, we put an open circle right here, and then we shade anywhere that's true for less than 3. So anything less than 3 gets shaded, so we're going to shade this direction on our number line. And typically I'll just then put the arrow on the end saying, shading that way infinitely. Again, I'll explain a little bit more about this open circle right here, this open circle, on the next slide. But what an open circle tells you is that 3 is not a solution. That's why it's an open circle. So would it be true if I put a 3 right here for x? Is 3 less than 3? Nope, it's not. 3 is not less than itself 3. So that's why right here is an open circle. Let's try this next one. This one says x is greater than or equal to negative 2. Again, greater than or equal to. So now I'm going to put a negative 2 on my number line. And again, we can kind of fill in a few. So to the left will be more negative, so negative 3. And to the right will be more positive, so that's negative 1. Again, we could put in more values if we want to, either direction. Okay, so now, when I put the circle here at negative 2, am I going to leave that circle open? Nope, I'm going to close it, which means you're going to shade it in. So this circle right here at negative 2 is going to be a filled in circle because it says right here that x has to be greater than or equal to negative 2. So if I put negative 2 in here for x, well, yeah, negative 2 is equal to negative 2. So it's going to be a filled in circle. Then it says, again, it says x is greater than or equal to negative 2. So greater than negative 2 will be to the right of it, where the numbers get larger. So again, we shade to the right here, and we can put an arrow saying that the solutions go to the right. So these two graphs show us all the solutions for those two inequalities. Again, any number over here is a solution, is a solution to this inequality. Any value that comes after negative 2 to the right of negative 2 is a solution to this inequality. Okay, so to solve and graph an inequality, here are the steps. First of all, we solve by undoing the order of operations, just like we did with equations. Remember, the order of operations are parentheses, exponents, multiply, divide, and add and subtract. And undoing them means we're going to start here and we're going to work our way this direction. Okay, the only difference, and this is pretty important, the only difference is that when you divide by a negative, we're going to need to flip the inequality sign. Okay, and I'll show that in at least one example. Number 2, we're going to graph the solution on a number line, and we're going to again use that open circle when, here we go, use the open circle when we have a greater than symbol or if we have a less than symbol. Again, because if it's like x is greater than 3, 3 is not included as a solution because it's not greater than 3. We're going to use a closed circle if we have greater than or equal to, or if we have less than or equal to. All right, so let's try an example. Negative 7x plus 2 is less than negative 5. So we're going to start by solving, and I'm going to subtract, and again, our steps are over here. Okay, we're going to start by adding or subtracting. We're going to do the opposite. So since we have addition of 2 right here, we're going to subtract 2. So I'm going to take 2 away from this side and take 2 away from this side, just like we do when we are solving equations. These will cancel. We're left with negative 7x is less than negative 7, because negative 5 minus 2 is negative 7. And now we are going to multiply or divide from left to right. So we're going to divide both sides by negative 7. Since negative 7 divided by negative 7 right here cancels out because it becomes 1, we're left with x. And here is where we have to be careful, right? What I said is that if we divide by a negative, we need to flip the sign. Did I divide by a negative right here? Sure did. So this less than sign needs to flip and become a greater than sign. And now we have negative 7 divided by negative 7. Negative divided by a negative is positive, and 7 divided by 7 is 1. So our solution set, our set of solutions, is where x is greater than 1. So on our number line, we start by putting 1 somewhere on our number line, remembering that 2 and 3 go this way, and over here is 0, negative 1. Okay, so on this number line, we want to show where x is greater than 1. Well, since this sign is just simply greater than, we don't want to include 1 as a solution, so we're going to put the open circle at 1, and then we have to decide which way to shade. And again, the numbers, the answers, the solutions, where x is greater than 1, well, give me one example of a number that's greater than 1. 2, right? So we're going to say, all right, we know that 2 is part of the solution right here, so obviously the shading is going to need to go this direction. So we're just kind of, you can test out a point and see if it would be true. We're going to shade that direction, again, infinitely. Those are all of my solutions. Okay, let's try a couple more. All right, to solve this next one by the order of operations, we are going to first we can do one of two things. We can multiply this with this 1/3 here by distributing the 1/3, or we can divide both sides by 1/3, which is the same as multiplying by the reciprocal. So a couple different options. I usually prefer to get rid of my 1/3 or any of my fractions by multiplying each side of the equation by the reciprocal. And remember what that means is if I multiply by, instead of 1/3, 3/1 on this side of the equation, my 3 and my 3 will cancel out because it's 3/3, which is 1/1. And then all of this becomes just the number 1. So then 1 times 3x plus 6 will just be 3x plus 6 is greater than or equal to. If I multiply the left-hand side by 3/1, I have to multiply this side by 3/1 as well, which is just another name for 3. So -1 times 3 is -3. Now we'll continue solving with our undoing of the PEMDAS steps. We're going to subtract 6 from both sides. And we're going to get 3x, because the positive 6 and the negative 6 cancel, is greater than or equal to -3 minus 6 is -9. Now to solve for x, I need to get x alone or with a coefficient of 1, so I divide both sides by 3. The 3 divided by 3 is 1 here, and we're left with an x. Now, do we need to flip the sign right now? Do we need to flip the sign? No, we do not, because we didn't divide by a -3, we divided by a +3, and that does not mean we flip the sign. So I'm going to leave the sign the way it is, and then -9 divided by 3 is -3. To graph our solution, we have to graph every value that is greater than or equal to -3. So I'm going to start by putting -3 on my number line. If I want to go a little more negative, I have -4. If I want to go a little more positive, I have -2. I have to decide which way to shade. Well, x has to be greater than or equal to -3. So here's -3. Am I going to shade that circle in? Yep, because it can be equal to, so it is greater than or equal to, so we're going to shade the 3 in. And where's greater than -3? Well, the values to the right are greater than -3. -2 is greater than -3. It's still negative, but it's greater, a larger number. And we also know that this will become -1, and then 0, and then into my positive values. All right. This one has variables on both sides of the inequality, so we have to remember our solving steps here. First thing I'm going to do is I'm going to combine my x terms, my terms that have x in them. I have 9x on the left, I have 6x on the right. I'm going to combine them by doing the opposite operation, so I've got to subtract 6x there to cancel those out. And I can subtract 6x right here. 9x minus 6x is 3x. And we have plus 6 is less than, these cancel, 21. Now to solve this, we're going to subtract 6 from both sides of the inequality. These cancel. We have 3x is less than 15, 21 minus 6. We're going to divide both sides by 3. 3 divided by 3 is 1, so we have 1x is less than 5. 15 divided by 3 is 5. So our solutions are any number that is less than 5. X is less than 5. So if I start my number line at 5, and again, this would be 4, pardon me. Try that again. 5, we're going increasing to the right, always increasing to the right. So this is 6 and 7. This way would be 4, 3. We're going to put a circle at 5. Are we going to shade it in or leave it? We're going to leave it because x is less than 5, not equal to. So where is x less than 5? Well, 4 is less than 5, and 3 is less than 5. All these numbers to the left will be less than 5.